Let's investigate the role of diagnostic medical imaging with artificial intelligence. Today's radiologist uses artificial intelligence as a tool to help them with diagnostic image reading for cardiology, radiology, and specialty PACS. The weakest link in a radiology imaging chain is the human, because the humans use subjective senses to interpret data, which is machine-generated and objective. Artificial intelligence is a tool for physicians and radiologists. AI provides data but cannot think as a human. Recent advances in computer science and robotics are rapidly producing computational systems with the ability to perform tasks that were once reserved solely for humans. Increasingly, doctors are calling on artificial intelligence to analyze and help in diagnostic imaging. While AI can sometimes spot concerns that a human might miss, it is not perfect. Digital medical images are created from data that can be gathered and reconstructed for several different uses. Data is real and objective, whereas interpretation of data is subjective. In medical imaging, the data represents the interaction of energy with tissue. The human decides on what energy is to be used by which modality and what information is to be obtained. This graphic displays how CT and MRI data are combined to create a fusion image. MRI data shows us the physiology and CT the anatomy. We can fuse those images to see anatomy and physiology at the same place. The remainder of this presentation will concentrate on the roles of the computer and the human in this process. Artificial imaging technology can only record the data that has been requested by the human. The data gathered is real, and the interpretation of the data is subjective. The human interprets the data using their senses, which may or may not detect the reality of what has been captured. This is best demonstrated if we analyze the old paradigm. If a tree falls in the forest, does that fall make a sound? Some will say absolutely there is a sound, and others will say if you did not see it, hear it, feel it, smell it, or touch it, it did not exist. Using our sight to interpret diagnostic images is subjective, whereas the data that is provided to artificial intelligence is real. This graphic shows the components of artificial intelligence. As artificial intelligence systems continue to evolve and learn, our world becomes more efficient and consequently richer. If we rely on artificial intelligence to bring us into a new world of labor, security, and efficiency, we need to ensure that the machine performs as planned and that people can't overpower it to use it for their own ends. Intelligence comes from learning, whether you're human or a machine. Systems usually have a training phase in which they learn to detect the right patterns and act according to their input. We need quality thoughts as a basis for human intelligence and quality data for artificial intelligence. The validity and the source of information determines the degree of the quality. Though artificial intelligence is capable of a speed and capacity of processing that's far beyond that of humans, it cannot always be trusted to be fair and neutral. Artificial intelligence cannot replace doctors, but it can help guide physicians. As we discussed earlier, each individual human is unique. There are no exact duplicate humans, while machines can be precise and reproduced. The verdict is out on just how much movement medical diagnostics might benefit with respect to artificial intelligence. While computers are precise and recognize patterns, human beings must rely on their senses to interpret data. Humans perceive reality through their senses. Computers do not. What a human perceives cannot be directly translated into data or used by a computer. The computer sees reality as it is and documents it. No two humans perceive anything the same or identically. Therefore, diagnostic readings are subjective, and they can even change if a human takes a look at a later date at the same data. The eyes translate light into image signals for the brain to process. Sight is the primary sense utilized in diagnostic imaging. In reality, medical images are not the way you perceive them. Your perceptions and your subjective influences such as culture make a difference in how you interpret an image. This is the reason that many people think of medicine as an art instead of a science. Medical imaging is a primary component of patient diagnosis. Medical imaging is the technique and process of imaging the interaction of energy with tissue of the body for clinical analysis and medical intervention. Understanding the evolution of technology will help us to understand how to better interpret images. The radiologist's uptake of AI solutions is driven by how effectively and seamlessly they can integrate with their current workflow and interpretation of the images. Using AI as a solution, the radiologist can focus on the interpretation of the image. Machines can recognize clinical problems in digital images ahead of the radiologist's charge with making the diagnosis. The radiologist can use the information collected by the AI to help them interpret the examination. The system analyzes medical images and then combines the insight with information from the patient's medical records to offer clinicians and radiologists support for decision making. Computer software reading medical images can match or, in some cases, outperform human radiologists. Hundreds of images can be taken for one patient's disease or injury. Imaging and radiology are expensive, and any solution that could reduce human labor, lower costs, and improve diagnostic accuracy are beneficial. Artificial intelligence that is used for diagnostic image analysis is evolving and learning constantly. The foundation for these systems is artificial intelligence, machine learning, and deep learning. This process tries to emulate the human brain. Let's take a look at some of the components that make up artificial intelligence, and remember, artificial intelligence is comprised not only of artificial intelligence components, but machine learning and deep learning. Using proprietary algorithms, machine learning is a technique for recognizing patterns that can be applied to medical images. Machine learning typically begins with the machine learning algorithm system computing the image features that are believed to be of importance in making the prediction or diagnosis of interest. The machine learning algorithm system then identifies the best combination of these image features for classifying the image or computing some metric for the given image region of interest. This graphic shows a comparison between the human biological neural network and how it works, and a computer neural network and how it works. Here we see a simple image of George Washington. We'll call it input. It is identified on the input layer, and the image is broken up into pixels. Pixels are picture elements, so we'll have multiple hidden layers processing the hierarchical features of the pixels by identifying the edges, combining the edges, and identifying the features. This information is then transferred to the output layer, where we choose those combination of features that we wish to visualize. Let's take a look at interpretation or decision making using the traditional approach and the potential of using AI. You'll notice there is much less involvement for the human using the AI technique. Analytics are extensively used to detect specific patterns identified with specific pathology. The imaging algorithms are capable of deriving metrics using intensive analysis of patterns in a given digital image and output scores that complement this analysis made by the radiologist. Deep learning or computer cognition, whatever its name is, it's the same thing. It is machines recognizing clinical problems in digital images ahead of the radiologist charged with making the decisions and using these as the guidelines. Here we see the analytical process of an AI algorithm and all of the factors that it takes into consideration. Let's take a closer look at this process. Take a moment and look at this graphic, and if you need to, rewind and visualize it again so you can understand the process of creating an AI digital image. To sum up, learning systems are really good on a narrow domain, but they do not do transfer learning in different domains like reason by analogy. Computers are just horrible at that. In the final analysis, it takes a human to analyze and use their subjective and learned knowledge to create a diagnosis. Computers and AI are simply a tool used by healthcare professionals.